Okay, so my name is Clint Zeagler. I am a senior research scientist and the program manager of the Wearable Computing Center at Georgia Tech. Like Diane mentioned, my background is a little, I have a little weird path to that position. My undergraduate degree is in product design, industrial design. My graduate degree is in fashion design. And I'm almost done with a PhD in human-centered computing. So at Georgia Tech, I teach classes that range from design classes to ubiquitous computing classes. So Diane saw a talk that I gave at the International Symposium on Wearable Computers called Where to Wear It, Functional, Technical, and Social Considerations and On-Body Location for Wearable Technology, 20 years of designing for wearability. 20 years ago, Francine Gemperle and others wrote a paper called Designing for Wearability, and a lot has changed in 20 years about the types of computers that we're trying to put on the body or technology. So for instance, I tend to use the term wearable technology now rather than wearable computers, but in the beginning it was like, how do we put a whole computer on a person and have them use it? And so I wrote this paper kind of giving an updated version, and in doing that, I also created a series of what I called body maps, which explained where on the body technology should go and why. And there were two main reasons that I had for writing this paper. One was because I wanted a quick reference instead of writing a paragraph every time I wrote one of my own papers. Because whenever you're dealing with a research study or creating a product, if you're writing about it academically, you have to validate why you chose the body location you chose. So part of this is that better? Should I use both? Okay. So part of writing this paper was specifically to address that concern about being able to have a quick reference. Another part of the paper, or another reason for why I wrote the paper, was to create a tool for designers to use that might not, I'm going to turn this one on, sorry. Is to create a tool for designers to use that might not understand or go through all of the thought process that I go through every time I make a decision about why I'm putting something somewhere on the body. So to talk about that tool, really quickly, I'm going to go through kind of my idea for how people work together. Right? So this is a framework about building that tool and other tools like it that I have worked on. Okay, is this better? Much better. Okay, so so in doing that, David Guest and Tim Brown from IDEO described this idea of a T-shaped person, and a lot of designers have heard this before. But a T-shaped person, when they're looking for a designer, is a person that has a breadth of knowledge, but also a depth of knowledge in a specific skill or a specific area, right? So you have empathy and breadth to be able to talk to other people, but you have your own expertise and something that you know a lot about. So when we work on a team, we'd hope that that teamwork, like collaborative teams, would look like this, where you have a number of people and they're all able to talk to each other, but they all have their individual strengths to be able to bring those to teamwork, right? In actuality, a lot of the projects that I work on look more like this, where you have someone where they have an empathy and breadth of knowledge like an HCI engineer, but that doesn't come anywhere close enough to being able to talk to a musician or a fashion designer or an architect. And this is even in the terms that they use, right? When you say the word design, it means something completely different to each of these people. So when I work on these teams, I kind of feel like I look like this. I'm a more interdisciplinary type designer. So I have this weird background where I have training as a fashion designer, so I understand the design process and the timetables and even the workflow that a fashion designer would use and their design process. And I also have an understanding on the engineering side, right? So I'm able to talk to engineers. And most of the time when I work on teams like this, I'm actually acting as more of a translator so that the people can actually talk to each other through me. But what if I'm not there? So that's where this idea of an interdisciplinary artifact came about. And it's something that I'm using the term boundary object to describe. So Susan Starr in a paper described what she called a boundary object. And if you're interested in diving deeper in this type of research, we have a paper about a case study of us using a boundary object in a team with a musician to create a piece of wearable tech. Okay, so a boundary object is an analytical concept of scientific objects that inhabit intersecting social worlds. Basically, they're flexible enough in meaning that two people can look at it and build a shared meaning, but they're also inflexible enough so that they don't just mean anything, right? So it's this balance. So this is why I tried to create these body maps, to be able to give them to groups of designers and engineers to be able to look at to create a shared meaning. And also, I was trying to create graphic representations so that a designer, without going through the litany of academic papers that I went through to create the body maps, that they'd be able to look at it and have a quick understanding of, oh, if this is important to me, then these are the places on the body it should go. And we'll get into examples of that. So, okay, we're going to talk about some human factors concepts that the human factors team probably knows a lot about, but there should be some quick stories in here that that some of you might find interesting from wearable technology. And again, this is all about all of these human factors are with a skew towards if I want to put wearable technology on the body. So proxemics is the concept of how far things stick off the body if I put them on the body, which means the classic example of that would be when you outfit a new football player with shoulder pads, they bump into everything, right? They run into the side of the door frame, or like my dog, for instance, if you put the cone of shame on her, she ends up hitting the side of the door when she's walking through. It's because she hasn't included that in her like personal space, right? So this also happens with wearable technology. So an example from the wearable tech community comes from the Symbol ring scanner. So this is a very interesting paper. If you read it, in part of the paper, they designed the initial scanner out of hard plastic, but it kept breaking because people use it as a shield against falling boxes in the warehouse. So they moved to a softer ABS plastic, but because of proxemics and people not being used to having that additional shape on their arm, as they reached for boxes, it would rub against the boxes, and eventually that ABS plastic just rubbed off to where you could see the actual circuit board, right? So it's important to think about those things, proxemics. These problems don't come up as often anymore because our sensors and the things that we're creating are a lot smaller than they used to be. Weight distribution is another area. So this map is a combination of some military studies about load balance, about load bearing on the body and where you can carry weight the easiest. I would say this map isn't as important today because a lot of the wearable tech that we're making is smaller because sensors are smaller. But when Thad started wearing a computer, you were using a motorcycle battery, right? So then it becomes important when you start putting a 3-pound motorcycle battery to be able to have a full day's charge on a computer. 7 pound. Sorry. But even here at Google, the design around weight is important. So in the paper that goes along with the body maps, Mark Spitzer is quoted as saying that people really wouldn't wear something on their face, like glasses for a heads-up display, if it was more than 75 grams, then really it should be about 45 grams. So in the design process of glass, what's interesting is in the beginning, the prototypes started with what are all the features that we need? And then after we have all the features that we need, how do we continuously make that smaller, right? Somewhere about halfway through the product design of glass, this product, the prototype linen was developed, and the idea here was the opposite. So part of the team worked in the opposite direction and said, if we have 45 grams as our limit, what features can we put into that, right? So it's an interesting way to design to put that limit on there as something that's a threshold that you know. Motion impedance. So this is pretty straightforward. Where can you strap things or put things on the body that aren't going to impede the motion of a person? So it seems like common sense, but as a research scientist and as an academic, I need to like build a case for why I'm not going to put the electronics in the elbow, right? But it's not a good place to put something because then you can't bend your elbow, right? So you don't want to impede motion. So this, I'm going to talk a lot about guidelines and affordances. So I think it's important for me to kind of define them. So within the paper and with the body maps, they each come with a set of guidelines. And when I say guidelines, what I mean is a set of considerations that a designer, engineer, researcher, or scientist should contemplate and incorporate into their process when working on a theme where those set of guidelines are important. So something that's a set of considerations at the beginning of a process, right? And affordances, when I say affordances, I mean what an object, or in this case, in a lot of cases, the body, allows at a certain position. So an affordance for an object would be a handle affords being able to pick it up. If I want to measure heart rate, there's some places on the body that afford that measurement better with the sensors we have than others. So that's about what the body can afford. Recently, I've been really interested in the body's sensation of touch. So this is a simple body map that shows areas used for active touch. What I mean by active touch is investigative touch. So you're seeing the fingers are mostly where we investigate things, right? Feel for things. But it can also happen with the mouth or with the feet, right? So sometimes you might accidentally feel a Lego with your foot, right? But sometimes people will grab for things with their feet, right? So that would be an investigative touch, active touch. And then these would be the guidelines that come along with this body map. So some simple considerations. One is just following good human factors and industrial design standards. So for interfaces, a lot of those are laid out in some basic literature that you probably already know, the Henry Dreyfuss book. And this also, all of that knowledge accounts for on-body interactions as well, right? So convex things will be easier to feel through active touch than flat things, right? Passive touch, I'm also very interested in. And so this is the body's ability to feel touch. So mainly what I mean by passive touch here is just noticeable difference. In Mancini's paper, this is a graphic from Mancini's paper, whole body mapping, spatial acuity for pain and touch. So basically looking at just noticeable difference here, which is like how close can you put 2 points on the surface of the skin before it feels just like 1 point instead of 2 points. And that's a way that scientists have described the body's sensitivity to touch. And so some design considerations that have to do with this idea of passive touch, specifically when dealing with vibration. Also, would be vibrotactile displays should be programmed to account for masking and vibrotactile adaptations. So this is the idea that like not just touch, but also vibration, how close can vibrating motors be together before they feel like one? And that also has to do with the frequency of the vibration and the pattern of the vibration. Are you vibrating at the same time or across time? So one vibrates and then the other vibrates. So there's a lot of interesting things to figure out here. My current active research is actually in this idea of active and passive touch. So if I'm placing an interface on the body, what's the easiest way to present that interface to a person so that they can use that interface without visual attention? So using embroidery to create active touch textures to be able to feel for an interface. And also what happens when we start to create surfaces underneath the fabric that project against the skin statically and or with vibration, right? So how can I show someone an interface before they use it as they're about to use it? Moving back into the body maps, one of the main differences, or one of the differences between when Gemperle wrote her initial paper and this follow-up, recap paper, is that a lot of what people have been trying to figure out with wearable technology is actually how the body's moving. So for use in fitness tracking or motion capture, how do I put sensors on the body to figure out how the body is actually moving, right? And there's a number of different reasons for doing that, and a number of different sensors for being able to do that. So here we're looking at, do I want to know where the whole body's moving? So that might be a gyroscope and a GPS sensor placed somewhere on the body, or in combination talking to each other. Do I want to know the force of motion? So how hard am I pressing on something to be able to move? So this could be pressure sensors, right, on the bottom of the feet, or where a person interacts with furniture, or even on the hands. If I'm in microgravity, I'm pushing away from something. If I want to know the movement of an arm or a limb, then I could place accelerometers on those extremities and get growth movement. But if I want to know if an arm is bending, then I might want to put a bend sensor across the elbow. So these are all different types of sensors, and where you place them on the body can give you different information. It may seem, getting back to why I made the maps, it may seem straightforward to us as designers or human factors people who are working at Google. But if you're working with a designer sometimes you might even have to go to the level of explaining, like, an accelerometer is something in your phone that can tell whether you're like flipping your phone back and forth, right? So being able to work with a designer and say, well, these are the reasons why a bend sensor wouldn't work in a certain location, and having a graphic to be able to talk over is another reason why I thought it'd be nice to make these. So just some examples, right? So this is from a book that Thad and I and Tavener and Maria Wongsala wrote, which is basically like a history of wearable computing towards a consumer computer book. This is a jacket that Johnny Farrington developed that uses a type of a knitted conductive textile that changes in resistance when you stretch it. And so when it's placed over these bending areas like the arms and the torso, you can tell the position of the body as opposed to where the person that's wearing it is moving. And then this is just a classic example of a use of a bend sensor, like an early use of a bend sensor, right? To be able to like bend your fingers, and that means something to a program, right? These were probably, these bend sensors at this time were probably just on-off type bend sensors, not giving you a range, just like have you closed your fist to make a punch or not, but still a kind of a nice callback. So if you went on the website that we have right now and looked at what's on, what are the body maps and what do you get? This is pretty much what you see. You'd see a body map, some short description of it, and then you would get design considerations, accessibility considerations, a number of references that help develop that body map. So if you were an academic, you'd know where to go look for specific things and be able to cite or find things that were really important to you. But if you're a designer, you have the graphic and the design guidelines. So back to working through those, we have thermal tolerances body map. This one is pretty simple because it's really looking at, this body map is looking at where can you place things on the body so that they will or they won't raise the body temperature. So placing things on the core, if they're gonna heat up a lot, again, they're going to raise the overall body temperature. This could be great if you had a ski jacket that had a really high-powered computer in it that was trying really hard to make something happen and heat it up, right? Then that would be great. It could be awful if you were in the desert and you had a high-powered computer that was heating up inside of a military vest, right? So it could be good or bad depending on where you are. There are also some other considerations, specifically thermal with skin tolerances, and you can go through those and read those if you're interested. But how long something is left on the skin at certain temperatures matters. So you can give someone a burn by leaving something on the skin longer, even though it's at a lower heat. That's important also to remember, especially when you're thinking about accessibility considerations. So for each one of these, there's design considerations and accessibility considerations, because I thought it was important to think of how we can make wearable technology accessible and think about that from the beginning of the process. Especially at a point right now where I think there's a lot of wearable tech out there, but if we move further in this direction, if we start thinking about accessibility now, then it will be baked in to the concepts that really take hold in the marketplace. So I'm going to run through these pretty quickly, but another change from when Gemperle wrote the original design for wearability paper and now is this idea of biosensing. So it somewhat gets back to fitness tracking, but also into health monitoring. And this is something that I think a lot of designers could really use, because when I talk to student groups, and they say, well, I want to make a blood pressure monitor, but I want to put it on the foot or something like that, right? They don't understand that the body accepts and reads that kind of information better in some locations than others. So you have to go through the process of like, what type of sensor are you going to use? And then where do those sensors work the best? So these biosensing maps, this one's heart monitoring, blood pressure monitoring, blood glucose. I included the eyes there because a lot of people are doing research into like contact lenses that will like read blood glucose. Respiration, so where can I read respiration? Temperature. And this last one, I think, this idea of hydration, but also stimulation. So when we think about galvanic skin response sensors, they can read that you're sweating, so you probably need hydration. But they also can look at stimulation change. So for instance, this is what a lot of wearables use for like sleep monitoring, to look at when you might be going into REM sleep and out of REM sleep. These are some early biosensors created by Body Media. Body Media was then bought by Jawbone, that now uses their algorithms in their products. This idea of using galvanic skin response to look at stimulation, right? The one on the Body Media Philips View patch is pretty interesting. I think it's a neat concept. It was a patch that you put on and it stayed on for 7 days. And then through the concept, what would happen is like your doctor would say one of these, and then at the end of the 7 days, you would bring it back and the doctor would take it off and then look at your rates like over those 7 days. It also has an accelerometer and other things in it as well. At Georgia Tech, Gregory Abald recently was using galvanic skin response and accelerometer on the wrist for children that were on the autistic spectrum to look at when they might be having a stimming episode. They didn't use it to measure anything, but what they did was they looked to try to figure out an algorithm of what that looked like, and then marked a video of when they thought it might be happening so that they could go back. So it was tagging a video so they could go back and look at what was actually happening. So that's an interesting use of this type of tech. Brain activity you have to do on the head. This is a fancy new mobile brain activity Bluetooth head that gives you some kind of information, right? I think you can also hook it up wired and it would give you a lot more. When it comes to brain activity, there's a whole range, right? It's it could be the one little node on the front of the forehead that's like, oh, your brain's active or it's not active, or it could be looking at different points, and there's gel and dry. So it all depends on what type of granularity and the detail of the information you want to get. Reachability. So for a wearable, this is really important. If you can't reach it easy, you're not going to use it, right? So being able to reach something to interact with it. So if you need to interact with the wearable device, you need to be able to reach it. Right arm, left arm. Another map we have, it seems like there's endless maps. Another map we have is reaction time to visible feedback. So if I'm going to place an object on the body and then I'm going to give you a visual feedback, a blinking light, or the screen like brightens or changes colors when something happens, how long does it take for you generally to notice that that is happening? So this research was done by Chris Harrison, and this is just a reinterpretation of his research into this body map. But I think it's a pretty interesting thing to know, right? So it seems obvious, right? If you put something on the back of your head, you're not going to notice if it's blinking or not. But there are areas where we've been trained or we innately notice more. Networking from on-body to off-body. So this isn't as big of an issue now when there's 3 or 4 Wi-Fi routers in a room and you could get to it in any direction. But if you're creating a project where you're creating a prototype or a case study, it's good to know where to place things on the body for that. For instance, and also to explain to the user, right? So on the left is a musician that we created a wearable for at the Wearable Computing Center. We had a 1-week case study with him. And we created this textile that he could touch, and it acted as a music controller. So he was basically creating loops and using the textile to create music. But it was a case study and it was a prototype. So every time it left the network, we had to reset the whole thing, and it took about 10 minutes, of course, you know. So He starts to perform, and right before his performance, he sees a friend in the crowd, and he walks off the stage to hug the friend, and he comes back, and his Bluetooth connection's gone, right? If it had been a guitar, he would have set it down because it had a cord to it, and he didn't want to unplug it to go. So simple things like that you have to explain when it comes to networking. Also, on the right, we created a musical performance garment for a dancer named Catherine Helen Fisher. And we placed it on the shoulder just like the map said to, and it had a Wi-Fi connection. But she's a dancer and she's not as tall as me, for instance. And so, it was a closed network and we only had one Wi-Fi router. So when I walked up to her to interact with the garment, it was an interactive garment that you touched to control the space, video and lighting and stuff. My body would block the signal, and then it would hop off the network, and then we have to reset the whole thing. That was solved by us just having more Wi-Fi routers. But it just shows you that these things still matter. Typical garment and seam constructions, this is important if you are creating a garment with distributed sensors. So if you're distributing sensors across a garment and you need to run leads between one area of a garment and another, then probably you're going to want to run those leads in a seam. So knowing where the seams are on a garment, especially if you're not, if you don't pay attention to those things, or if you're not a fashion designer, is helpful. For me, it's a little bit of a full circle moment. So to be able to run those leads between different sensors on the body, especially if you're measuring capacitance. So a lot of what I measure is a capacitance change, or a current leakage across two conductive surfaces. You need a twisted pair because capacitance changes as you move. So if you just run a single line, or if you run a parallel line across the arm and you bend your arm, that's actually going to change the sensor of what I'm trying to sense. That's actually going to change it more than touching the place that I want you to touch. So you have to have a twisted pair. So we created this twisted pair out of fabric and conductive thread, which also happened to create bias tape, which is what you use inside of, which is what you use inside of nicer jackets and stuff like that to seal seams. So it's great because what we made is what you would use both in the fashion industry and in a technical application. So it's a twisted pair bias tape. Sometimes things work out like that. Social acceptability is also important, especially if you're interacting with things on the body. So we've done a number of studies, one in particular where we looked at the social acceptability of interacting with things at certain point, interacting with textiles specifically at certain points on the body. So if I'm interacting with a piece of fabric on my wrist, that's a lot more acceptable than if I'm interacting with a piece of fabric on my waist, right? One really interesting thing that came from this study was, this study was done across two different cultures. So we had Americans take an online study and we had South Koreans take an online study. And we had a pilot study before we got into the final study where we were just looking at type of interaction. So whether you tapped the fabric or slid or swiped across the fabric or rotated on the fabric. And the Americans picked one version and the Koreans picked a completely different version. I can't remember which it was at this point. What's interesting for me is that as soon as someone like Google put a commercial out that said we're developing something and people saw that interaction, they would think, oh, that's how people interact with these types of fabrics. But before that, there was this strong cultural divide, and I have no idea why. But past that, the places on the body where people interacted was pretty typical as to what you expect. So the wrist and the forearm was a lot more socially acceptable than the waist or the pocket. And then depending on female to male, like on a jacket was better for males than it was for females on a lapel. So the designer and the graphics person in me was like super excited to get to this point, because I was just thinking about how are all these things going to overlay with each other and how pretty is that going to be? And I want to like get this printed and make like a bodysuit out of it. But the idea here is that if you weighted all of these considerations the same, where on the body would wearable tech generally go? And I think that that's an important part of it is if you weighted all of those considerations the same, right? So you can see here the wrist and the hand and the head and the chest and the bicep and the forearm tend to be where things would go. And that's where we tend to see them too. So moving past that into some current work and some future work that I hope to see. So we have an upcoming journal publication called the Assistive Wearable Inclusive by Design. It's going to be in Assistive Technology Outcomes and Benefits journal. So this journal paper is a longer version of the paper that the paper that I published at ISWIC, the International Symposium on Wearable Computers, but it focuses on this idea of assistive technology, so and accessibility. So how do we make these things accessible from the beginning? But what it also does, which I think is interesting, is places the body maps or even boundary objects and talks about where that should happen or where that could happen in the design process. So this design process that you see up here is actually a larger process that includes policy, because at the Wearable Computing Center, we have a couple of people that work on policy design. And we have a paper that where we talk about the design process merged with the policy design process. So thinking about how will this affect policy when you're designing, and also thinking about what policy there is as you're designing, right? So I think a lot of times we look at rules and regulations, but we also don't think about how will what I'm working on affect future rules and regulations. So that was the initial paper. And then here we look at this paper at where these body maps, where design considerations and guidelines should go into that process. So you can see, I don't know if you can see my cursor, but you can see that it's here right before and as you're moving into these design components. And it's all iterative, so all those things come back, right? So future work. The slide before that slide, I was talking about if we weighted everything the same, what does that body map look like? What I really want to do as a next step in this body map process is actually create a web tool so that if I'm a designer, I can go to this web tool and answer questions. So I could answer, for instance, if I said I'm making a heart rate monitor, then I could answer a couple of questions like about heart rate and what I wanted to measure. And then that would give more weight to the areas on the body where you can measure those things in heart rate, right? But then also I can say, but it has to be really socially acceptable or nobody's going to use it. Well, then that's going to create more weight in that. And as you start to throttle the weights of what you as a designer think are important for your wearable design, I'm hoping this web tool can build a heat map and also selectively give you the references that are important for you to think about, the academic references, and accessibility considerations that are important for the part of the body that heat map might develop for. So that's my end goal for this, is a more interactive tool for designers, not just designers, but a designer could use it by themselves, but if I gave this tool to an interdisciplinary team or transdisciplinary team, where I would have a designer and an engineer sitting together, thinking about those choices together, then I create a process for them and a shared meaning for them, in a way that I was talking about the boundary objects earlier. So that's my talk. Thanks. And I'd love to answer questions.